All right. Hello, everyone, and welcome. I'm Karan, and I manage developer relations for GitHub in India. And I'll be talking about how to deploy to DigitalOcean using GitHub Actions. So, before we move on, a quick background about me. I've been in the developer relations space for many years now, helping developers globally with technologies around cloud and DevOps. I'm also very passionate about open source and focused on helping grow the open source community and get more people to give back to the open source projects that they are using, as well as find it very helpful. All right, so moving on, before we get into deploying to DigitalOcean with GitHub Actions, let's take a quick look at what is GitHub Actions and how it's useful. And then I'm going to show you a demo of how to deploy to DigitalOcean using GitHub Actions. So what is GitHub Actions? GitHub Actions basically is a world-class CI/CD tool, and it's fully integrated into GitHub. From the merge box to the check tabs, from the UI to the API, it's all in there. And you can trigger a job on any GitHub event to automate any workflow in your team. And since many of you know, community is at the heart of GitHub. And anything you build with GitHub Actions is shareable because it's just code in a repo. You can make it public, you can fork it, you can edit it, you can customize it. And well, you can do whatever you want with it. And finally, you can use it to work with any platform, any language, and any cloud because it's totally interoperable. And because Actions is built in to GitHub, there's no need to manually configure or set up CI/CD, to set up webhooks, to buy your own VMs, to patch them and keep them up to date, monitor it, do cost management, shut down IAM VMs, etc. Just drop in a workflow file in your repo and you're up and running, just like magic. But if you want, you can manage all of these yourself as well. More about it later. The other thing is Actions also support matrix builds. So you can run parallel jobs across OS versions, runtime versions, or any variable you want to use to multiply your workflows. Action gives you real-time feedback with streaming logs that are searchable and also deep linkable. So you can share a link to a specific line of a log with a friend to get help debugging a build. So you don't have to keep on searching, or your team doesn't have to keep on searching. Oh, where did that line go? Where did it go? Where is the error, etc. You can just deep link it and share the streaming logs. And also to help integrate with third-party services or deployment targets, every repo on GitHub has a built-in secret store, and Actions will substitute secrets for your tokens. So you don't have to hardcode anything or even manage secrets separately outside of GitHub. And finally, because it's GitHub, Actions are easy to write and easy to share. And this is how core software development works today. All right, so before moving on, let's take a quick look at what are some of the core concepts of Actions, because we'll be using this in the demo while we are deploying to DigitalOcean later on. So Actions are reusable components and they live in independent repositories. So it's written in JavaScript using Node 12. So you can write your own actions and with the help of the Actions toolkit, even publish it on the marketplace for others to use it. And you can even use Docker or point to existing actions published to Docker Hub. Workflows are at the core of how Actions and your whole automation runs. And they are kind of like the glue which put together all the different actions. They listen for particular triggers. In this case, where you look at the arrow pointing to 1, the trigger it's listening to is on push. So when anything you push into the repository, this workflow gets triggered. And you can even run shell scripts. In the example 2, there's a run with the remove command which is running. Or you can even run pre-existing actions like in what you see in 3. There's an action that is already pre-existing which is just being used. And the best part is Actions run in VMs. So you can use a Linux, Windows, or Mac, or even a Docker. And this is especially helpful if you are running some specialized applications for build or doing any kind of matrix builds and you want to do builds across various different operating systems. All right. A few key things to keep in mind regarding workflows. And again, we'll be taking a look at it later on in the demo. So the pieces are events, and these are the ones which kick off the workflow. Like how I was mentioning before in the example, push is one of the event which kicks off the workflow, or it could be pull request, or it could be multiple others that's available on the GitHub API. And jobs are one of the other pieces of a workflow, and these run in their own VM and they are in parallel unless you specify other ways. We look at that as well. And these specifies the VM as well. So in a job, you can specify what VM it runs on, whether you want it to run on a Linux or Windows, a Mac OS, or whatever you want. And steps are the individual tasks within a job, and they run in the same VM and share the file system across the job. And then also, like how I mentioned, logs. These are pretty cool. And logs are searchable and they link to individual lines, and you can also share the artifacts among various pieces of the workflow. So here's an example of a basic Java plus Maven, a basic CI workflow, just to give you a feel of how it is. If you look at it, it's a single job, which is called as build, and it has 5 steps. You can see that it runs directly on the VM, in this case, Ubuntu latest. And then you can also see that the actions are composable. The first one action is checkout, which basically, check out the files from within whatever triggered that workflow. And then also there is a setup which is available, so you can quickly get started with various different languages or frameworks on actions. And Maven is run by a shell command, and you can see that the artifact is uploaded separately through the upload artifact action. And just going a little bit around, event triggers, like how I mentioned, just one example is push, but you can listen for multiple events as well. In the example, you can listen for push, pull request, branches, tags, and so many others, which is there on the GitHub API. And you can qualify these as needed as well, like how it's shown in the example. So on create of a tag, you can do it, or you can even specify for a branch when there's a push for a branch of master, or even filter pattern like a regex, or you can even schedule it with a cron syntax. So you have all the power to decide how you want that workflow to get triggered. And steps is where all the magic within actions happen, because they are the heavy lifters of what happens in your workflow. And steps can run other actions. So these can be things like checkout, or when we saw in the previous example of any other action, you can use it from the marketplace, community build, etc. Or even you can use your own action that you built. It can even run command line scripts or even multi-line scripts, all within the workflow step itself. How cool is that? So how do you get started with actions? Now, there are multiple ways where you can do this. One is, if you want to use any of the pre-existing actions, just head over to the GitHub Marketplace, github.com/marketplace, and there are thousands of actions across various different frameworks, languages, tech stacks, platforms that you can use in order to customize your workflow. Here in this particular session and the demo, we'll be looking at the GitHub action for DigitalOcean, where you can use doctl within your workflow command to interact with your DigitalOcean account. All right, so I'm sure that all of you are excited to take a look at the demo. So let's dive into the demo of seeing how to deploy to DigitalOcean with GitHub Actions and how you can do CI/CD. But before that, let me give you a little context of what demo we are actually seeing. So here is an example application, a demo, which is called OpenMCT, Open Mission Control Technologies. And I've chosen this only because, it gives these really cool graphs and everything else that you can see the application running. And this is a mission control framework for visualization of data on desktop and mobile devices. it's a Node.js app, and it's open source under Apache 2.0 license, released by NASA. And for this specific demo and example, I have Dockerized it so that I can show you a little bit more about how builds happen and also make it easier for the deployment process as well. And here, what we're going to do is we're going to assume that we are going to do a staging release of this application where for every staging release, a new droplet will be created and this container will be deployed so that you can test it out, or your teams can check it out, or even at a further later point you can configure the workflow to do like a rolling deployment as well if you want, etc. So that's the scenario. So we're going to do a staging release, and that staging release will trigger creation of a new droplet and deploy our container over there. Let's jump into the demo. All right, so here I have the demo, which is my demo repository called OpenMCT tutorial. You can see that I have forked it from NASA/OpenMCT tutorial. And this repo basically has a few examples and also a tutorial of how to get started with OpenMCT, which is the reason I'm using this. The only modification I made over here is I've added a Docker file, a deploy script, and also added a workflow. So let's take a look at the workflow and go through it. You can see over here that the name is staging deployment, and the trigger is when there are any push of tags with name stage hyphen star. So this is a filter pattern, which means anything that starts with stage hyphen triggers this workflow. You can see that I have two jobs over here. One is the build job and one is the deploy job. And I have added a deploy job as needing a build job, which is a dependency, so that my build artifacts, in this case Docker images, are ready before deploying. So let's take a closer look at what this workflow does. In the build job, this runs on Ubuntu latest VM, and the first step is to check out the files, which is a pre-existing action, which basically checks out the files that is within the specific commit of the tag which triggered this workflow. And after that, I'm using a action build and push Docker images, which is a pre-existing action. And the arguments that I'm passing are the username, password, repo, etc. And you can see that the username and password here, I'm getting it from my secret store within the repository. We'll talk about it in a little while. And the deploy job will run once the build job has been completed successfully. It also runs on Ubuntu latest VM. And the first step, I'm again doing a checkout of the files. And the second step, I'm getting the tag name. And this is a community action, a pre-existing one which I'm using. And the reason why I'm getting the tag name is because in the latest step, the droplet I'm going to create will be the name of the tag itself. So in the third step, I'm doing an install doctl so that I can use the doctl command line to interact with my DigitalOcean account. So this is the official action of DigitalOcean, and the argument that's required is the token, which is the DigitalOcean access token of the account, which I'm passing it again through secret. And in the last step, I'm provisioning the droplet and deploying the container by using a shell script and using the doctl compute droplet create command. The name of the server being get tag name, and this is exposed by the get tag name action that we've used before. And the image that we'll be using is a Docker one-click using Ubuntu 18.04. And the size is the $5 droplet. This is the slug of it, region NYC1. And I'm also passing a user data file with the deploy script, so that once the droplet is ready, the user data can be run, which will basically pull down my container image and then start a container with it. And I'm also passing the flag wait. So let's go ahead and create a new tag and trigger this workflow and then see what happens. So I'm going to go back into code. I'm going to create a new release, which will automatically add a tag. I'm going to say the name of the tag is stage-v1. And with the release title, I'm going to say this is stage v1 .0.0. I'm going to mark this as a pre-release because this is just a staging release for me. And I'm going to say publish release. So this would have created the new tag, which would have triggered my action workflow. So let's go take a look at it. And indeed, you can see over here that my staging deployment workflow has got triggered. Let's take a look at it. So it's currently queued and it has started right now. So here are the streaming logs that you can see and all the various different steps that was configured within our workflow. And here it has pulled the first action, it has checked out the files, and now it's doing a build and push Docker image. So while this is running, let's quickly take a look at where you can find the secrets within the repository. So if you go into settings, you can find in the left nav secrets, and here is where you can add the secrets for your repository, which can be used in your workflow file. You can see that I have Docker Hub username, Docker Hub password, and DigitalOcean access token as my secrets that can be used over here. Coming back to the workflow, I can see that the npm CI is running right now. So this will probably take a few more seconds. Meanwhile, if you have to check out the DigitalOcean action for GitHub, you can do so on the GitHub Actions Marketplace. If you just search for DigitalOcean, you will get the GitHub action for DigitalOcean DOCTL, where the usage of it is mentioned, and also how you can use it, and the arguments being token and version as well. So cool thing is within this, there's also a link to a repository where the team has done a really great example of how to use GitHub Actions with DigitalOcean. In this case, how to use a Kubernetes cluster on DigitalOcean and how to create a deployment using deployment.yaml. So if you go into the workflow of this example, you can see this example over here where there's a container which is being built and pushed into the DigitalOcean container registry, updating the deployment files, saving kubeconfig, and then deploying to DigitalOcean Kubernetes as well. So this would be a great, example of a workflow if you were to do a production deployment, and you can do that, say, by using a release as a trigger or anything else, or a merge to a master, or anything that suits your workflow. So let's go back and then see. So here I can see that the build and push Docker images is complete. The checkout is complete, and the job is also complete in 2 minutes 16 seconds. Here in the left, I can see a deploy job which is running. If I go check on my DigitalOcean console, you can see that the deploy is going on, which is the provisioning. So here it's waiting for the provision to complete, because I've added that as a flag. And it's complete already, and it shows me that the droplet has been created with the name and also the public IPv4 address and exactly what I wanted. You can see the check mark over here indicating the workflow completed successfully with both the jobs. And if I go back into my console, I can see that the droplet has been provisioned and also with the IP address. Usually once the droplet has been created, running the user data scripts take a little while, but since it's DigitalOcean, I'm expecting that this is going to happen really, really fast. That's one of the things that I really love about DigitalOcean, is how fast it is to provision a droplet and get it up and running and ready. So I know the droplet is ready, and most probably the user data and the deployment script is running. I'm going to give it probably a few more seconds for this to complete. And there you go. I can see this automatically refreshing and my application is up and running. This is one of the things that I really love about DigitalOcean, is how fast it is to get up and running. So if I go into the example, which is the demo example spacecraft, and if I say go into the generator voltage telemetry, I can see sample telemetry data come into the application, and this is really cool. So if we look at it and go back into the actions and see how long it took 3 minutes 34 seconds to build the images, to push it to Docker Hub, to provision a droplet, and also almost to get the user data script up and running. So that's how fast it can be to use a GitHub Actions workflow along with DigitalOcean. So you can check out more, and I would definitely recommend you to give this example a try. That's included in the Actions repository of the example doctl action, to try it out with DigitalOcean Kubernetes as well. All right, so that was the demo. I hope you liked it. And before we wind off, I have a few pro tips for you. Shh, don't tell it to anyone. I'm just kidding, this is for everyone, and you can use it. So one of the things that probably I haven't mentioned is you can trigger workflows externally as well. So it doesn't always have to be triggered only through the GitHub API. You can use the on repository dispatch trigger event, and you can do things like post to it as well. And the other thing, which I also mentioned before, is you can schedule workflows with a cron syntax. If there are things that you're doing continuously, for example, every day or every week, you want to do some linting across or whole of your code base or anything like that, which you want to do at a periodic time, you can use cron. One of the other things that we saw in the demo was to resolve the dependencies across jobs. You saw that the deploy job was running only after the build job because we had mentioned it as a dependency. Similarly, you can resolve dependencies across multiple jobs as well. Here you can see that job 1 is independent, which starts off first, and then job 2, for it to start, it needs job 1. And then for job 3, similarly, job 1 and job 2 should be completed successfully. You can manage these dependencies as well. Also, one other thing is you can run a job based on previous step exit status so that you can make your workflow a little more robust and also control how the execution happens. So here you can see you can use if conditionals with things like failure, success, cancel, always, and there are other things as well which you can look at it on the GitHub documentation workflow syntax as well. And the last thing that I also was talking about is you can use the built-in secret store, and we saw this in the demo. We did not use our DigitalOcean access token directly, but rather used it through a secret store which was available within the repository. Also, if you go to github.com and the docs section, you can find multiple articles and also many community articles out there of how you can get started with GitHub Actions if you're using other CI pipelines like Circle CI or Jenkins, or even things like Azure pipelines, etc. And if you want to learn more, a little more, and you want to get a little more hands-on of how to use GitHub Actions and how to do DevOps, there's a cool learning lab course on lab.github.com called DevOps with GitHub Actions, which is a path and individual courses as well. And the great thing about the learning lab courses is it all happens within GitHub. So you interact with the code right within GitHub and build the action and use your GitHub workflow itself to learn things the GitHub way. All right, so to help you get started, I've put together some resources for you of where you can get started, learn more, etc. And now, since you can't just click over here and get the resources, I've created a short URL for you which points to my GitHub repo where you can get all the resources that you need. And the last thing, and this is where you can use your DigitalOcean account as well, is you can run your GitHub Actions on your own hardware for free with self-hosted runners. So Self-hosted runners offer more control of hardware, operating system, and software tools than GitHub hosted runners provide. And with self-hosted runners, you can choose to create a custom hardware configuration with more processing power or memory to run larger jobs, install software available on your local network, and choose an operating system that's not currently offered by GitHub hosted runners. And this is where DigitalOcean can come in as well. You can have a hosted runner on a DigitalOcean Droplet or even on DigitalOcean Kubernetes. And GitHub Actions is free for all public repositories. And our aim is to support the CI/CD needs of any open source community that wants to use GitHub Actions. And because GitHub Actions is community powered, Actions help enterprises enable inner source and accelerate innovation by harnessing the collective knowledge, not just within their organizations, but also from the broader community. And we think Actions provides a great way to learn from the community by reproducing every step of your favorite projects, then forking them to suit your own requirements. And one of the most amazing things about GitHub is that it's not just a tool, it's a platform. And every day we see the different ways that developers and companies are extending to GitHub to do new things. That's really, really cool. And what's really exciting about Actions is that it broadens the way you can interact with the GitHub platform and providing new APIs and events. And now any third party can use Actions to trigger a CI/CD build. And you can choose tools from any of our partners like Circle CI, CodeClimate, CodeCorv, CloudBees, and others to build your perfect workflow. GitHub and we give you the choice to do that. And we're working with all of these great companies to provide really useful interaction with GitHub Actions. So if you haven't checked it out yet, you should definitely check out with so many cool things that you can do. You can also head up to the GitHub blog where we have shared a lot of the stories of how the community is using GitHub Actions to do a lot of other cool things. And do check out and try out and see what all you can accomplish with GitHub Actions. If you do something new and cool, please do let us know. We'd be really excited to know more about it. So, all right, and that was about how to deploy to DigitalOcean with GitHub Actions. Thanks a lot for being tuned in. And if you have any questions, please feel free to reach out to me. I'm available on pretty much everywhere. And have a great rest of the conference. See you all again sometime soon. Take care.